Last minute it becomes a problem. Started. Alsona, I can see Alsona.
Mama, you can see me?
No, I saw you in this YouTube. It started.
Acha, like that. But for me, it's not opening.
See now. I can see.
Now I can.
So no.
Yes, ma'am. So working. All participants. Vinny ma'am, that our resource person's surname, how should we pronounce it? It's Ghosh only, no?
Ghosh only, yeah.
Okay. Ma'am, soon we'll reach 500 subscribers on YouTube.
Alsona, yesterday, Alsona and Daya, yesterday, this Father Swami called up. You know Father Swami who he is?
Yes.
He is the principal of St. Mary's ICSC also, no? And he called up and he was asking about this mathematics webinar. You're doing such a good job, madam. Then I said, yes, Father, what happened? Then he's telling all my teachers are attending. Some of the teachers are regular in your mathematics webinar and all.
Yes, St. Mary's, no? St. Mary's ICSC school.
ICSC, yeah.
Yeah, I saw a lot of teachers in the responses.
Yeah, so she's telling that I will make them compulsorily attend now. This one, I sent him the flyer. Then he's telling, oh, a very good one. He's telling I will compulsorily tell them to attend. Yeah,
for us, ma'am, more participants.
Yeah.
Ma'am, after a few years, we'll also come as participants.
After a few years, इसके बाद ही.
We'll come as alumni.
I am feeling so sad now. Your year is getting over now.
Ma'am, then you will tell your that batch students that were my students, alumni students.
Yeah, we have to integrate them now. Yeah, slowly.
Ma'am, you'll not forget my name. No, you said you'll not forget All Gold.
All Gold, I will not forget.
All Gold.
Yeah, Daya, I said, see, if I forget anybody else's name, I love gold. So also I will not forget your name. All Gold.
I remember, like, the first time she told me her name, no? Remember, Alsona, we were in the library. That's how I think I first spoke to you. And I couldn't, like, Alsona, जब नाम बोला तो you only said, like, all Sona, ऐसा याद रखे, ऐसा कुछ तो, right? That's how you say.
I tell people that only if they can't.
Yeah, so that people remember it. So after that, I actually did not forget. I actually forget names usually, but your name I remembered.
No one will
And
forget.
Daya, you also said, Daya, darwaja tod.
Yes, ma'am. My name, no one can forget. I've been listening to this for like so many years.
Achha, resource person is
Memorable name.
Okay, ma'am.
Okay,
ma'am, you have to make me the co-host.
Yeah, yeah. Liesel is not there, no?
No, today she is not there. Good evening, ma'am.
Good evening, ma'am.
Good evening.
Good evening, ma'am. Good evening. So, you all set for the session?
Yes, yes. Very excited about today's session because it is going to be hands-on and going to be a very good session.
Good evening, ma'am.
Good evening.
Good evening,
Vinny ma'am. You have to allow me to present later on.
Yeah, I'll make you the co-host.
Okay, yeah.
And Clarice, you're doing it alone or you're doing with Daya?
No, ma'am. Half of the part Daya is doing.
You can make me also the host or co-host, and then
Yes,
I will switch off those annotations in the beginning.
Yes.
So that
Daya also I will make.
I think the annotation gets activated only when we present screen, right?
Yes. Also, now you'll manage the waiting room, no?
Yes, ma'am. Yes.
And madam, no, madam is she's not going to be there throughout. So she said first 15 minutes and then she will go and then she'll come back again. So I said, when you come back again, you message me. Then we will see, I said.
Yes, we'll keep that 10 participants grace in the room.
Yeah.
But the others who are co-host, like in the initial period, don't admit all because we need to keep the count.
Yeah, Daya and Clarice, you all will not admit anybody. Huh? Don't admit anybody.
Yeah, okay, ma'am.
For the YouTube, if there are queries from YouTube participants, will they be able to?
Yes, ma'am. I will be looking into that and I'll let you. Yeah.
So, Daya, you are looking after the YouTube.
The YouTube one, and Nisha will be looking after the Zoom one. So if there is any in any of the, it's less, then accordingly we'll adjust.
Okay, sure.
It's like too much on one side, so accordingly.
Okay. So,
ma'am, if there are queries, I think you're going to solve sums as you were saying. So if there are queries on YouTube, let's say, related to sums, so I can interrupt and ask?
Yes, please. Whenever there is a query, please see, I will not be able to see once I do my full screen because I don't know, in my Mac it is like that. I cannot see anything else at that time, but you are welcome to just stop me and interrupt me, and I'll sometimes, when you're doing hands-on, like I'll be showing something on a spreadsheet, then people will want me to repeat it if they have not followed the steps or something. Although finally, in the recording and when I share the PowerPoint, there are slides which give the steps also. Like if someone wants to go through that separately, on their own.
Okay.
So, but then sometimes during the session, people stop and,
so if they say like repeat the step or something, that also I can let you know, right?
Yes.
Okay, thank you.
Sometimes, I ask the question when, about the problem, like what are your first thoughts or what do you think the answer is to this and all. So people start take a few 1 minute, a few seconds and then start responding. So when if many respondents come up with the same answers and you say, man, this seems to be the common answer or something like that, you can always tell me. This is the only way you can make it interactive in this online mode. So
yes, it's difficult this way.
yeah. So I just wanted to know, you are a school of education, right? I mean,
yes.
So you run B.Ed programs?
Yes,
Teacher education programs.
Yes. This is B.Ed.
Right.
2-year B.Ed.
Correct.
So these are our SY B.Ed students and they've already passed. They are already in the SEM 4 and they are now going to finish their the B.Ed now. So this is like their last lap, 1 or 2 months remaining.
Right. So the mathematics component must be the teaching of mathematics kind of courses,
Yeah,
right?
so we have a paper.
Pedagogy.
We have a paper, pedagogy of mathematics.
Right.
So in that we learn all the mathematics, teaching, learning methods and everything related to maths. It's a nice paper.
I teach the same actually. I teach in a program which is a 4-year undergraduate program called the Bachelor
Okay.
of Elementary Education, which is run in some colleges of Delhi University. So we do have in the 4th year they have a course called Pedagogy of Mathematics, which I teach. Then first year and second year also, first year and third year also they have other courses, mathematics courses. So
Dr. Haneed's class was also very good, last time.
yes, I saw her session. I saw the recording she shared with me. And I think Jayashree Subramaniam also did one session, no? Hello?
Hello.
Yeah, it froze for a second. Jayashree Subramaniam also.
Yes, yes.
But Honey session, was it 1.5 hours? I don't remember.
Yeah. Went till 2 hours.
Oh, 2 hours.
Multidisciplinary approach. It was very good. And
Yes.
she had made those small videos and all that she was showing us.
Yes.
It was very interesting.
Very
Yeah.
interesting. We both, I also have my own YouTube channel where some of these things, I have made short videos. Then we did some lectures for the NCT, National Council of Teacher Education, Open Education Resources. So we had, when the COVID thing started, so she was a part of the committee which was to develop some online courses. So she did some, then she roped me in, then I did some. So we do have some video recordings also.
So give us your YouTube address, the channel address, so we can also look at it.
Yes. Like lot of GeoGebra videos are there and some spreadsheets also.
We had Professor Inder Rana coming to us to speak to us about GeoGebra.
He is doing this international GeoGebra conference from
Okay.
11th to 13th of March.
He's an expert in GeoGebra.
Yeah, he's
Quite an expert, yeah.
He's
He's using it now. At the time IIT, no, he's in.
Yes, I know him for many years. He started the Time conference, no? TIM.
Okay.
You know about that?
No,
That's
I don't.
something. It's a biennial conference, means once in 2 years. So every odd year, TIME stands for Technology and Innovation in Mathematics Education.
Okay. When does it come?
Abhi announcement आएगा because this is 21. So every odd year it is being held.
Okay.
Started in 2005 and 5, 7, 9, 11. So it has been going on. Last one in 19 was held. It's always in December. It was in Isa Pune. And so we are all in the national committee which organizes that conference. So lot of work. But he called me the other day, and so he is been very good with. He does a lot of. I think he does this thing called making mathematics meaningful. It's a project. Set of workshops with teachers, and teachers go and teach those things in their classes, and so the math education community is quite active.
Yeah, really. And I didn't know about it. Since I entered into this webinar, only I've come to know that it is so active. Very nice.
How long, ma'am, you've been teaching in this course? And
25 years.
Pardon?
25 years.
Oh, okay.
25 years, yeah. Just completing now.
Mm-hmm.
So, Dr. Susama Samuel, our principal, is here. Good evening, ma'am.
Good evening, Vinny, Dr. Vinny.
Yes, good.
Doctor, and good evening, Dr. John Ghosh.
Good evening, ma'am. A pleasure to be here.
How are you?
I'm very well, thank you, ma'am. It's a pleasure to associate with you and your institute. I heard a lot about it, so.
You are welcome. You are welcome to SXI.
Thank you. I was just, sharing with a friend that earlier all these kinds of sessions used to be live, and it was always fun to travel to another city and interact with people, and all that seems to have gone.
Okay.
Yeah.
So where are you now? You are in Delhi?
I'm presently in Delhi, yes.
In Delhi. Okay. So classes are going on, no?
Yes, ma'am. In fact, since last month, we have been earlier we were doing online classes from home, but now we've been asked to sort of come to college and take online classes.
Okay. Okay. Okay.
Which I don't mind, honestly. I live very far away from my college, but I don't mind the travel because it was just getting very, very, just sitting at home and
Yeah.
taking
Yes.
online
Yeah.
classes now somehow.
Right.
But what about the cases there? It's in control, Jonaki?
Cases, yeah, it was very much in control, and then suddenly now we are hearing there are slight rise in Delhi also. Um, but people are, I guess, working with that social distancing mode. I can see that masks are a common feature.
Yeah.
I recently traveled to Rajasthan, Jaipur, and there I saw people, all the masks were at the chin. so,
Yeah.
so it's become an embellishment for the chin, but
Yeah, that's
it's not then serving any purpose. But yeah, in Delhi, I think people are becoming more, we have become more. But Maharashtra, I can see, and cases are on the rise again.
yeah, it is in the rise now. That is what we are hearing. We don't know exactly. This is all we come to know all through media only. No, that is the
Correct,
thing.
correct.
Like,
Correct.
yeah.
So, ma'am, where in Mumbai is your college situated?
It is in Churchgate.
Oh, Church. Okay.
Churchgate, very close to the station.
I know. Actually, I lived in Mumbai when I was a child. I studied in my schooling. Part of my schooling was in the Villa Teresa High School.
Oh, very nice school.
Yes. Then my father used to be posted there in Mumbai. So I was there for 3 years. Uh, Middle school I did there. Then I moved from there too.
Okay, very nice school. Stone building, no?
Yes. Very beautiful school. And
Very beautiful, yeah. So now, like you're in Delhi, you're with your family.
yes, yes. I have a daughter. She is presently in grade 12. So she is appearing. It's a horrible year to be in grade 12.
Yeah.
So she is taking all her entrance exams now.
Okay.
Vinny ma'am, sorry to interrupt, but it's 3:46.
Okay, you post, no?
We'll put the links.
Yes, yes.
Okay. Daya, you will put both the links on the groups, WhatsApp groups.
Okay, okay. I'll just do.
Do you think most of the participants are from Mumbai itself, or?
No, all over. From Dubai, United, yeah, Arab Emirates also we have people.
Nice.
So, and all over India, many states in India, they are there.
Oh, wonderful.
So this is one advantage of technology, no?
Yes, yes, absolutely.
Yeah.
And the numbers are certainly much larger.
Yeah.
So, although now we are seeing the trend that if 500 people register, maybe 200 join. Actually,
Yeah.
but in the initial months of the pandemic, we were
Many of
having
them.
an overwhelming response.
Yes.
Ma'am, I'm starting to admit people. Father Blaze is coming.
Now, what is coming?
Father Blaze.
Yeah, he said he will come. That's why I just messaging him.
Okay.
But you leave some space, no?
Space, yes.
When would you like me to present screen and remove the annotation thing? Disable the annotation by participants? Would you
When
like?
you just start presenting, no, that time only you disable it, Jonaki.
Yeah. Sure.
Good afternoon, ma'am.
Good afternoon.
Good afternoon.
Good afternoon, everybody.
Good afternoon, ma'am.
Good afternoon. Please mute your mics when you join.
Good afternoon, ma'am.
Good afternoon.
Good afternoon. Good afternoon, ma'am.
वो जानते जानते दो चाय भिजवा देना यार।
Vinay ma'am, you're not presenting the presentation.
Oh yeah, forgot. Forgot totally.
And we have to start recording also.
I'm going to try all this thing. This is the area where the parents do not know, but the teachers know about this.
But I didn't know Ricky's a manicure.
म्यूट कर रखा है।
Every single time I eat bhujia, I always have one thought. Where does this steroid
With 5 rupees, what you'll get more? इसको बंद कर दो।
मेरे को दे दे, वो मेरे को ज्वाइन करना है।
वो गया
Hello.
Okay, so I think there's 1 minute left. Alsona, you can.
Yes, ma'am, we can start.
1 minute left. Dr. Susama, can we begin? It's just, ma'am.
Yes, yes.
So good evening, participants, and welcome to the Mathematics Webinar Series 8 under Strategies and Solutions for Boosting Mathematics Learning. I request our principal, Dr. Susama, to start with a few words.
Good afternoon, everyone. Respected Father Blaise, our manager, my colleagues, teachers, and all participants. On behalf of St. Xavier's Institute of Education, I welcome all participants to this webinar on strategies and solutions for boosting mathematics learning. It is conducted by the mathematics unit of St. Xavier's Institute of Education under the guidance and initiative of Dr. Vinny Sebastian, Associate Professor, and also mathematics pedagogy students. It is a monthly webinar series, which is actually started from the last year, 2020, and this is the 8th webinar in this broad topic, strategies and solutions for boosting mathematics learning. The other past sessions, the last sessions also dealt with various pedagogies related to mathematics teaching and mathematics learning, and also related to innovations, and a few sessions were on research based, and the resource person shared the research findings with the participants. And also the mathematics unit conduct need-based researches, small researches along with this webinar series, which helps to identify the need for conducting webinars and also actions in this regard. Today's topic or today's session is on technology-enabled explorations, a catalyst for developing mathematical thinking, by Dr. Jonaki Ghosh from Lady Sri Ram College, Delhi, who is a young teacher educator. She is with us. When we when I heard the term, I was thinking of like the role of technology. Today, we know that when we are comparing to the past decade or past few years, we know that technology has influenced the whole teaching learning process into a different level. We know that today learning is also taking place in a different level when we compare to the past years. And we know that every day we hear about some new thing, or we are learning new innovations which are related to the exploration of technology, or which is the role of technology in teaching learning process. So due to this, teaching learning is become more, we know that today it is become more lively, more interesting, and also it is more customized. Like, it is like in a personal, we can use it like at a personal level, as per the personal need, personal interest, we can use it. So it is become more customized also, because we know that the technology is very flexible, and we know that we all have accessibility to the technology, and it so that it brings like in a quality in teaching or learning of mathematics education. So when we think of that, the exploration or the word explore or the exploration due to technology, we know that the limit is the sky is the limit, and the scope is very much broad. We can use the technology for mathematics teaching and learning in various ways, and in various strategies can be used, which will bring definitely mathematics learning and mathematics teaching more interesting. And the purpose of the seminar or this webinar is also the same thing, only to bring interest in mathematics learning. We can say that to develop interest and to make mathematics easy, so that the students can enjoy it, and also teachers will enjoy teaching the subject. So today, Dr. Janaki Ghosh is also, I think she is going to take us into a new level, because definitely the technology is such a subject, she can take us into a new level to explore various areas, and also how technology can be used in, I think her topic is like, developing mathematical thinking, or to increase the mathematical thinking in students. So definitely she is going to take us into a different level, and we can experience it today. So on behalf of St. Xavier's Institute of Education, I welcome Dr. Janaki to this webinar, and also all the best, madam, to your session, and all the best to all participants for being here. And also I wish all the best to Dr. Vinnie Sebastian and her team of students in exploring new areas, because this is also a new area that she is taking initiative, she is taking interest in making mathematics learning or mathematics teaching easy. So all the best to Dr. Vinnie Sebastian and her team of students, and all the best to participants. This session may be definitely sure it will be a very interesting session, and we will enjoy the session through technology. So I once again I welcome Dr. Janaki to this seven. All the best to her. So over to Dr. Vinnie Sebastian.
Thank you, ma'am, for those encouraging words. A few announcements before we start the webinar. One is that this is the webinar series 8, and we have already completed 7 webinar series. And we hope that this webinar series has been helpful to all of you, and you are using the resources what we are providing to you in your classes. The main aim of conducting these webinar series by St. Xavier's Institute of Education is to bring in the change in mathematics teaching learning. This is our main objective, of bringing a small change which will lead to bigger changes in mathematics teaching learning. So we want to see the change in your teaching, in your students, a smile on the faces of your students. And as ma'am says that, yes, we want everyone to enjoy mathematics teaching and mathematics learning. So that is our main objective. And we have always said that whenever you are doing any innovation in mathematics, please send us a 1-minute video of your innovation. We would be putting up on our mathematics channel, which is Mathematics Learning. We already have a number of subscribers to the YouTube channel. So these webinars are put up on the YouTube channel, and you have to log on to the YouTube channel Mathematics Learning for the resources which we are putting up there. The email ID is mathslearning@sxie.in, mathslearning@sxie.in. So if you have any queries, or if you want to tell us something about your innovation, you are free to send us your messages or videos on mathslearning@sxie.in, St. Xavier's Institute of Education. So this is one thing I want to say. And second thing is that St. Xavier's Institute of Education has entered into a collaboration with Homi Bhabha Science Center of Education. We had already sent you a Google form asking you what kind of courses you need, short-term courses. So we have got number of responses, and we have taken an action on those responses. So we are going to launch our first course on fractions. On fractions, a small course, it will be a 1-week course on fractions. So the information will be coming to you via your email. We are already collected the participants' email address. So we will be sending you the brochure of the course via your email ID. And all those who are interested, we would like to know. The course is on fractions. It will be a 1-week program. So let us know whether you are interested in joining that course. And as madam said, that every session we present a small action research We send a questionnaire to the participants and the participants respond to the questionnaire. So do participate in our action research program also. And we will also learn a lot, through your responses. So today we will be presenting a study on gender bias in mathematics teaching learning. After Madam's session, we will be presenting the results. Now, this session would not be meaningful if we did not have our student coordinators. So we have Riesel who manage the certificates, the registration form, the feedback form. Alsona is there who's managing the waiting rooms and the introduction. We have Rachel who will be there at the end, and Clarice and Nisha and Daya will also be managing the series during the session. So thank you very much to the student coordinators who are helping me. So we welcome our resource person, Dr. Jonaki B. Ghosh. And I thank you, ma'am, for accepting our invitation on the topic Technology-Enabled Explorations, a catalyst for developing mathematical thinking. Before we start, I request Alsona to introduce to us our resource person for the day. Alsona.
Good evening, everyone. It is my pleasure and honor to introduce our resource person for the day, Dr. Jonaki Ghosh. So Dr. Jonaki Ghosh is a faculty in the Department of Elementary Education, Lady Shri Ram College, University of Delhi, where Madam teaches courses related to mathematics education. Madam obtained her PhD in Applied Mathematics from Jamia Millia Islamia University, New Delhi, and Masters in Mathematics from Indian Institute of Technology, Kanpur. Madam's primary areas of research interest are in use of technology in mathematics instruction, professional development of mathematics teachers, and popularization of mathematics. Madam regularly delivers lectures and conducts workshops in national and international conferences such as International Congress of Mathematical Education, Asian Technology Conference in Mathematics, Technology and Innovations in Mathematics Education, etc. Workshops conducted by Madam cater to teachers from elementary school to senior secondary school. They focus on innovative practices in teaching mathematics through hands-on activities and technology and emphasize on enhancing the pedagogical content knowledge of teachers. Madam has published articles in proceedings of conferences as well as international journals and has authored books for school students. Madam has also set up the Ramanujan Foundation for Initiatives in Mathematics Education, which caters to professional development and training for mathematics teachers at all levels of school education. And the list goes on. So once again, I would like to welcome Dr. Jonaki Ghosh, and over to you.
Thank you so much for that kind introduction. Thanks a lot. I do hope it'll be an enriching session for me. I'm already looking forward to it. May I share my screen?
Yes. Sure.
Just share the thing. Have you made me?
Yeah, you are the co-host, so you can.
So I'm not sure whether this is. Can you see the slide?
Yes.
Okay. Just. Okay. So I'm just going to set the. Can you see now full screen? I mean, is it clear?
Yes, clear.
Okay. So yes, so that is the title of today's session. Hello?
I request the participants to kindly mute their mics and not disturb the session.
Okay, so as ma'am has already introduced, first of all, I would like to thank the Institute for inviting me, and I can see already from your from the little that you have shared that you are doing such a fantastic job of doing so many, engaging so many teachers in various activities related to mathematics education. And certainly this webinar series, I'm sure, will go a long way during the times of this pandemic. Special thanks to Dr. Vinny Sebastian for extending me this invitation. And so the outline, I just would like to share the outline of this session. So first, very, very briefly, I would like to mention, before we start off, I'd like to recall the goals of mathematics education and talk a little bit about the role of explorations in the mathematics classroom, but with specific examples of students' work. By students, of course, I mean a range of students from high school to undergraduate in a teacher education program. We will focus when we use technology, we will be focusing on spreadsheets. So we will look at MS Excel. And in some of the problems, I would request the audience to go along with me if it is possible for you. But even if you're not able to follow, it's fine, because I'll be sharing this slide. This presentation and some of the slides have the specific steps that you have to work on to arrive at the solution to the problem. Okay, so let us, as educators, we are always, or even as parents, we're always thinking about what are the goals of mathematics education. And, the position paper on the teaching of mathematics of the National Curriculum Framework 2005 gives a very beautiful statement. And it says, simply stated, there is just one main goal, and that is mathematization of the child's thought processes. But often teachers have asked me that, what does the word mathematization actually mean? What does it entail? And I often say that, one of the most meaningful definitions that I have found of the word mathematization is by Hans Freudenthal, who was a great mathematics and a mathematics educator. And he said, mathematics is, after all, a human activity. The pupil himself or herself should reinvent mathematics. And during this process, the learner is engaged in an activity where experience is described, organized, and interpreted by mathematical means. And this activity is called mathematizing. So I'm going to need to highlight the word reinvent. How much scope are we able to give our children, our students, to really reinvent mathematics? Are we really pushing the content on them, pushing certain concepts and ideas on them? Or are we allowing them to engage with those concepts and rediscover them for themselves? Is there a scope of doing that in the curriculum? So another great person who I often like to quote, and I'm sure many people who are in mathematics education do that, David Wheeler, in a small paper on an article called Mathematization Matters, he talked about what is mathematization and said that it is the ability to perceive relationships, to idealize them into purely mental material, and to operate on them mentally to produce new relationships. So when we want children to engage in an activity, are they able to pursue relationships within the concepts of mathematics? Are they able to see the mathematics? The capacity to internalize or virtualize actions and perceptions, and to ask the question, what would happen if? How much scope do children get to, ask what if questions in the classroom? What if I change this? What will happen to the problem down? If I change this parameter, or if I change this variable, or I change this condition? Asking those what if questions are very, very important. And the ability to make transformations from actions to perceptions, from perceptions to images, and from images to concepts. So it's a very beautifully written article, and I strongly recommend teachers to read this if they haven't already. So mathematics teaching, if we see, it entails, explanation of as a mathematics teacher, what is the maximum time, how much the time that we spend in teaching. Much of it goes in explanation of procedures, doing derivations, ensuring practice by students. And in the pandemic, during this time, multiple choice tests have kind of been the main mode of, testing, so to say. But the first approach is obviously everyone has been doing. The second approach, where students actively solve problems, engage with tasks, justify their reasoning and solutions, and that is elicit mathematical thinking. Now that is hard to do remotely, so I am now talking in the context of an online classroom. that it is perhaps hard to do remotely, but it is not impossible. And in fact, Joe Bowler has often talked about a balanced approach with a growth mindset. And we need to make our teaching student centered, which pulls in the student into the learning process rather than pushing content on them. And again, the position paper had made a very important remark about recommendation about making a shift from content to processes. So it said that, look, the content of mathematics is all well and very good, but what about the processes? Should we not focus more on the processes of learning mathematics, that is use of patterns, estimation, approximation, visualization, reasoning, proof, formal problem solving, and so on? And now my question, the little one that I have enclosed in the bracket, is, can this be done even remotely? I mean, in an online class? Can we? It is hard enough to do this. It's difficult to do this process of shift in a regular class, but can we do it remotely? And well, my feeling is yes, definitely. So today's session will focus more on how we can engage students in these processes of learning mathematics. So if you look at the inquiry-based approach, and specifically again with online teaching, because that's the reality now, teachers need to pose challenging learning experiences that activate students' mathematical thinking. And these may be in the form of specially designed tasks or projects. Students should get ample time to work individually as well as in groups. So, individual work is important, but working with peers and discussing problems is also important, discussing solutions. Finding strategies of solutions. Children should engage with their peers. Students present their work from time to time and receive feedback from the support of the teacher. The teacher takes a slight backseat, becomes a facilitator, and watches every student take part in the learning process. Students, of course, must take ownership for their learning. And technology has a very critical role to play and can form a major vehicle for exploration. And later, towards the end of the presentation, I will highlight how technology can play the role of an amplifier as well as a reorganizer. And I will elaborate on the meanings of these two metaphors more towards the end of the session. Okay, so there are many tools, available for mathematics teaching and learning. I am not getting into the big domain, like, there are computer algebra systems, there's dynamic geometry software, there are handheld graphic calculators. And I've had as a teacher educator and I have been a school teacher also for a fairly long time. I have spent enough time on engaging with these tools for encouraging students to learn mathematics. But somehow I have felt that, spreadsheets like what we are going to do today are generally overlooked and underutilized. They are in fact very powerful and can help in identifying patterns, generating graphical representations, creating simulations, and they're very suited for the inquiry-based approach. And when can be, of course, easily incorporated in online classes. And the best part of a spreadsheet is, even without knowing a high level of coding, one can engage in some problems. Now we are coming to the real stuff. All this so far was more kind of a setting the tone, or maybe you could say a background. But this is the menu for today. So there are 7 very fantastic problems. They are very beautiful problems. And I'm not sure whether we can do all 7. I don't think we'll be able to do all 7, but we will start off and let's see how it goes. The important thing is that you should enjoy this experience and you should engage with the problem. So far, have I been clearly audible to everybody? Has it been okay?
Yes, Janaki.
Very clear, yeah.
Okay, thank you.
Audible.
All right, so we'll start with the Fibonacci sequence. Everybody is familiar. I would say many people would be already familiar with the Fibonacci sequence. When you talk to the sequence about the children, two children, and they'll all also say, yes, ma'am, we know what it is. We know that Fibonacci sequence, this occurs in nature and so on. So let's see. So this is the famous Fibonacci puzzle. This picture is of Leonardo Pisano Fibonacci, also known as Leonardo of Pisa. So it is a legend. The story is that, in his book called the Liber Abaci, he talked about this kind of a puzzle which leads to the Fibonacci sequence. Okay. So it's highlighted in blue here, which says a newly born pair of rabbits are put in the field and are able to mate at the age of 1 month. So this newly born pair of rabbits is a male-female pair. They are put in the field and are able to mate at the age of 1 month. So that at the end of the second month, a female can produce a pair of rabbits. Again, each pair is male-female. Rabbits never die. I mean, this is just, it's a puzzle. So rabbits never die, and a mating pair always produces a new pair every month from the second month on. So how many pairs will there be in 1 year? That's the puzzle, the question. So I'd just like you to take a little minute and to just go through the problem and maybe share, if possible, by writing on chat that how do you think you would like to represent this problem? And is the idea clear? So there are newly born pair of rabbits. So let's say at this very moment, a newly born pair of rabbits are placed in the field and they are able to mate. They are only able to mate after they attain 1 month of age. And at the end of the second month, they will actually produce another pair. And this will always happen for every pair of rabbits. So by the end of the second or third month, how many pairs of rabbits will there be in the field? So, and how would you like to, more than the answer, how would you like to approach this problem? Would you like to draw some kind of a diagram to represent it? Or what would be your approach? So if in case there are any responses on chat, I would request you to share with me, else I will sort of go to the next slide. And
Daya and Nisha.
I hope the audience has been able to see the puzzle.
No response, ma'am.
Okay.
Check.
There is some number which is put up on the chat, no? 11235813, like this.
Yes. So that is itself is a Fibonacci sequence. But how did it come? How is it related to this puzzle? That is what I'm trying to ask. So okay, let me ask then. Let me see next. Okay. So let's see. There is a diagrammatic representation, a nice one at the back. But let me try to get you to respond. So suppose this is a timeline. Okay. This is right now. These are the months. I'm marking the months on this timeline. Okay. And right now there is one, I hope you can see, I'm circling it. There is one single pair of rabbits, male female pair. So obviously by the end of the first month, you will still have one pair, the same pair, the original pair. And at the end of the second month, this original pair will produce a new pair. So there will be two pairs now, the original pair and the newly produced pair. Now, this original pair was able to mate at the end of 1 month, but it can also mate at the end of the second month. So again, it will produce a new pair at the end of the third month. So at the end of the third month, how many pairs will there be? So if the audience could just answer this question, that at the end of the third month, how many pairs will we have? Because at the end of the previous month, you already have two. You have the original pair and the second pair. But at the end of the third month, the original pair will again produce a new pair. So there should be 3 pairs at the end of the third month. And similarly now, yes? Is there any?
Is it 3 or 4? Because I'm confused. There are some answers like 3, 4.
Yes. Next slide, I will show a pictorial representation which will make it clear. Now you just have to see that next month. Now come to the fourth month. You already have three pairs in the previous month. So obviously those 3 pairs will be there, right? So 3 plus how much? How many new pairs will I get at the end of the fourth month? Any responses for that?
Yes, ma'am. 3 plus 2.
Very good. 2, because the original pair which was in the field will produce a new. See, the original pair, any pair from the second month on will keep producing. No, this is what it says here. Rabbits never die, and a mating pair always produces a new pair every month from the second month on. So obviously there are already 3 pairs. Among these 3 pairs, the previous 2 older pairs will produce 2 more. So there will be 3 plus 2, 5 here. And it goes on like that. Next will be these 5 pairs plus these 3 pairs will produce new pairs. So there will be 5 plus 3, 8. Okay. So let's look at it this way. A very nice pictorial representation is there available in Google itself. Okay, so the black pair is the original pair. Now it's color coded, so it's nice. Now let's see. 1, 0, the first pair is the black pair. At the end of the first month, the same black pair remains and they are able to mate. At the end of the second month, this black pair produces this purple pair, newly born purple pair. So we have the black pair and the purple pair. So at the end of the second month, we have 2 pairs. Now come to the end of the third month. The black pair remains, जो पहले था वो तो रहेगा. So whatever was there in the previous month will always remain. So the black and the purple pair remain, but it is only the black pair which will now produce another new pair, which is the red pair. The purple pair will not produce because it is too young. It can only mate at the end of the first month. Second month on, the purple pair will also start producing. And this goes on. So at the end of the third month, we have 3 pairs, the red, the black, and the purple. Now let's go to the fourth month. These 3 which were there in the end of the third will obviously, these 3 will remain. But which can the audience tell me the blue pair and the green, the new pairs will be produced by which pairs? Now there are colors, so you can.
Black pair.
Black and purple.
Yes, very good. So let's say the black pair produces this and the purple pair produces it. The red pair is still too young. It can mate at the end of this month, but only second month on it can produce. And it goes on like this. So obviously at the end of the 5th month, all these 5 pairs will remain. So these 5 pairs will remain. The new pairs, the 3 new pairs will be produced by these 3 rabbit pairs. This orange color, the pink one and the brown one will be produced by these 3 pairs. So 8 pairs. So to get the number of pairs for the next month on, how many pairs will I have? So it will be simply the sum of the previous 2 numbers. These 2 will give me the new number of pairs at the end of the 6th month. And therefore, this is the Fibonacci sequence. So 1, 1, the number of pairs of rabbits at the end of any month. 1, 1, 2, 3, 5, 8. Now you can tell me what will be the next one after 13?
21.
21. 13 plus 8, 21. 21 plus 13 is
34.
34.
And it will go on, right? So I hope the idea is clear. I mean, of course, I could have just started with the Fibonacci sequence, but it wouldn't be fun unless I related it to the actual puzzle. And this is the puzzle, and this is how you get the sequence. Okay. So moving ahead, so Fibonacci sequence can be generated. So we say that our 2 initial values are 1 and 1 because initial pair, there's only 1 pair. And we add them to get the third term of the sequence. So, and every subsequent term is the sum of the previous 2. So 21, so we know 1, 1. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. And we wrote out the next few. Okay, let's do it just quickly again, just for the audience to be clear. So 13 plus 21 is 34. Next term will be 55. Next term will be 34 plus 55, which is 89.
89.
Next will be 55 plus 89.
144.
144. One
Next,
more.
233.
233. So if I know the previous 2 terms, I can always get the next term. And this can be written in a recursive manner. So this is a notation like, of course, the first Fibonacci number is 1. The second Fibonacci number is 1. The third Fibonacci number is 2. But for certain reasons, we can say that 0, F0, the 0th Fibonacci number is 0, because if we write it in the recursive relation form, where we say f of n denotes the nth Fibonacci number. So nth Fibonacci number is the sum of the previous 2. So it is the sum of the n minus 1th plus the n minus 2th Fibonacci number. And this is true, this relation is true for n strictly greater than 1. So obviously if I put n equal to 2, then I will need f of 1 and f of 0. So I need to define f of 0. So we say let f of 0 be 0. So using this recurrence relation, we can get this sequence very easily. Okay. So I hope that is clear. So this is just a mathematical notation and a way, a recurrence relation is a nice way of representing this Fibonacci sequence. Now we have to get thinking with about the sequence a little more. Now you are familiar with the sequence 1, 1, 2, 3, 5, 8 and you know some terms of the sequence. How many terms have I written here of the Fibonacci sequence? Like 233 is which term of the sequence?
13.
13th term. Okay. The 10th term is 55, am I right?
Yes.
13th term is 233. Okay. So can you guess how large will be the 40th Fibonacci number? 40th or even 50th. Okay, let's go with the 40th. How many digits do you think there will be? How big will it be? So, any guesses? You're allowed to make wild guesses. So even if you're wrong, it doesn't matter. I mean, we can all be wrong. It's always good to be wrong rather, because making mistakes helps us to think in a different way also. Anyway, there's no right and wrong here. It's just you can just make a guess, a random guess about how many digits do you think the 40th Fibonacci number will have? No guesses from the audience?
34, no, 5 digits they are saying.
5 digits. Okay, excellent. 5 digits. Any other number? Very nice. Somebody has said there would be 5 digits in the 40th Fibonacci number.
Somebody has said 4 and 10.
4 and 10.
4 and 10. Someone said 4 and someone said 10.
Yes.
And someone on YouTube has commented 6 digits.
6 digits. Very good. So they're all kind, and this is how it should be in a classroom. We don't want everybody to say the same thing, right? So somebody said 4, somebody said 5. So we have a range of responses from 4 to 10. Nobody for more than 10? Okay. Great. So yes. So the question was how many, so now we are going to do a little bit of an exploration. So I asked you how big do you think or how many digits do you think the 40th Fibonacci number will have? But we are also going to now look at the actual Fibonacci sequence and the ratios of successive terms. So let me rewrite the sequence here. So somebody can tell me the sequence. So we already know it is 1, 1, 2, 3, 5, 8, 13, 21, right?
34.
And so on, right? 55 was the 10th Fibonacci number. So now one aspect is, of course, I asked everyone to guess how big will be the 40th Fibonacci number. Then I also want you to look at the ratios, like 1 upon 1, then 2 upon 1, then 3 upon 2, then 5 upon 8, then 8 upon 5, 13 upon 8, and so on. So these ratios here, I've written them down in blue here. Where are they leading? Where are they approaching some value? Okay, that's one exploration we will do. Then we will take ratios of alternate terms. Then we will do 2 upon 1, 3 upon 1, leaving one gap, 5 upon 2, 8 upon 3, 13 upon 5, and so on. And see where is this sequence leading to and where is this sequence leading to. These are sequence with gaps of 1, alternate terms. And more importantly, we'll come to this also. Anyway, so now let me take you to spreadsheet. So if you have access to a spreadsheet, it will be nice. Otherwise, you can just watch. But you'll continue to think, right? So now I'm going to open an Excel sheet. So please tell me if it is visible. Is Excel sheet visible?
Yes, ma'am.
Yes, ma'am.
Okay, I need to enlarge it slightly. Okay, great. Now what I'm going to do quickly is, see, I always feel comfortable to have a column which is called the serial number column. So these are just headings I'm giving, serial number. In this column B, so column A is only going to have serial numbers. Column B, I'm going to create the Fibonacci sequence. So I'm just writing Fib. Column C, I'm going to take ratios. So maybe I'll call this the nth Fibonacci number. In column C, I'm going to take ratios. So I will say so ratios of successive terms. These are just titles, so don't worry. It's optional. You need not even write it, but this is just for your understanding. And in the next column, I'm going to have with gaps of 2. So again, I mentioned this is just a title. So I'm going to highlight this maybe in blue. Just center align it. So these are going to be the columns. So for the serial number, I just want a sequence of number. We said how big is the 40th Fibonacci number, right? So we need a sequence of numbers, say 1 to 40. So what I will do is in the cell A2, I'll enter this number 1. And in the next cell, I will put equal to sign, because when I enter a formula, what I want to do is I want to add 1 to the previous cell. So I'll say equal to, I click on the previous cell and I add 1. I hope this is clear. So I entered 1, just type 1 and press enter. And in the next cell, I will type equal to A2 plus 1, because A2 is the cell previous cell. You don't need to type A2, you can just click on the previous cell and you will get it. So those who are familiar with the basic functionality of a spreadsheet, you will know this. Even if you don't know, it is fine. So this is, so when I do equal to A2 plus 1, I'll get 2. And then because this cell A3 has a formula, I can drag it till I get, say, the first 40 numbers. I hope this is clear. So we just got, I'll just center align this. This is a serial number column. Now my Fibonacci numbers, the initial 2 numbers are 1 and 1. So I'll just type 1. So click on the first cell B2, 1, press enter, click on the next cell, press enter. And in the third cell, I need to add these 2 numbers, because every Fibonacci number is the sum of the previous 2 numbers. So I'll enter the formula equal to, click on this cell. I'm just clicking on the cell, please note, and plus click on the previous cell. So I must put an equal to sign because it's a formula. So equal to B3 plus B2, press enter. I hope it is clear to everyone. Because this is important, this formula is going to generate the Fibonacci sequence. So we press enter. Okay. Now having done that, you see that the first 3 Fibonacci numbers are now visible, 1, 1, 2. And the formula is in this cell. So I could drag further, but instead of dragging, because I already have a column to the left, I'm just going to double click in the corner of the cell. So when the cursor becomes a small plus symbol in the corner, I just double click. And that double clicking will evaluate the formula in the cell and create all the Fibonacci numbers. Okay. So let's do that. I double clicked in the corner of the cell and this entire column got generated. I've center aligned it. So now, do you want, those who made guesses, do you want to revise your guess? How many digits will the 40th Fibonacci number have? I can see the 23rd, 24th one. So the 24th number already has 5 digits. So I guess, whose guess was correct, do you think? We had somebody said 5, 6, I think someone said 4 and someone said 10 also, right? Okay, so when we scroll down, we see that this is the 40th Fibonacci number. I'm going to highlight it in red, just for. So it has 9 digits. So you see this is a very fast growing sequence, right? And you can also, you can easily graph this sequence also. We'll do that in a bit. We'll do the graphing in a bit. So is this clear how to generate the sequence? So all I did was I created a column of numbers from 1 to 40. And then in column B, I entered the first 2 values. So let me highlight these in red because these are important. These are the first 2 values of the sequence. And I entered a formula here, which was the sum of these 2 cells. And when I double clicked in the corner, I got the entire sequence. I mean, I got the sequence up to the 40th term. Is this idea clear to everybody? How to go about this?
Yes, clear.
Great. Okay. Now I said that I'm interested to know what happens to the ratios of successive terms. So what formula should I be putting here? Do you think? Because I need 1 upon 1, right? So what I'm going to do in this cell is put an equal to sign, click on this cell B3, divided by B2, so slash B2. This is again, I'm just entering a formula because when you evaluate this cell, it will give you the ratios of successive terms. Okay, so let me press enter. Obviously, the answer is 1 because 1 upon 1 is 1. But thereafter, next ratio should be 2 upon 1, which is 2. The next ratio should be 3 upon 2, which is 1.5 and so on. So all I need to do is again, as I did before, I just bring the cursor to the corner of this cell and double click. Okay, for convenience, let me center align this. And please have a look at this third column and tell me what is your observation. What happens? What do you think is happening after some time?
After decimal, the value.
Yes, ma'am. You're right.
So decimal also is the same.
So it tends to steady out at least to a certain number of decimal places. If I reduce the column width by dragging, see this was here, I bring the cursor to the joint between the C and D column and I just reduce the column width. Well, let me reduce it. So let's say we have about 6 or 7 decimal places. We see that after some time, it's all steady. Let me highlight this 1.618034. Have you heard of this? This is a special number. It's a special ratio. This ratio is called the golden ratio, which is very much there in nature also. And many architects in the olden days used to use the golden ratio in constructing buildings and so on. So this is the golden ratio. So, and what is this ratio? This comes by taking the ratios of successive terms of the Fibonacci sequence, right? So now I want to ask you that this number is steady. So what will happen if I make a change in the first 2 numbers instead of 1 and 1? Suppose I change the 2 numbers to something else. What do you think will happen? Will this ratio change? So of course, if people are trying with me, along with me on their own spreadsheet, they can change these two values and see, but without changing the values, first think. And then you can verify. See, when you're using technology, we are always tempted to jump and try and press the button. But before that,
change.
Sorry?
It will change. I guess
Yes.
it will change.
Yes. So one response is it will change. It is likely to change.
No,
because
it will not change.
See, if you change these two numbers, the entire sequence will change. Then how can this remain the same? I mean, that's a question children will ask, right? So I want to, from the audience, I want to say at least a yes or no. Will it change? Will it change? Yes or no? I can't see the chat, but
Many are saying no on the chat, on Zoom chat.
People are feeling that it will not change. So is that answer because you've tried it, or you intuitively feel it will not change?
Some is saying we are taking ratio, so it will be constant.
Yeah, but if it's a completely different sequence, then okay. So let's
Now
give
they're
it.
saying it will change now.
Yes, yes. Okay, let's see. So let us change. See, the spreadsheet is already there in front of you. You just need to verify your conjecture. So conjecture making is very important for the mathematics classroom. Don't press change the numbers and see right away. Ask the children for various, give them opportunity to think, give them opportunity to agree, disagree, thumbs up, agree. Okay. Okay, but since we have short time and we have lots to do, so let me change. Okay, I'll put two different numbers. You can give me the two numbers, whatever you like, or you can try it on your own spreadsheet. Let me make it 2 and say 7. Okay, so when I change the first two numbers to 2 and 7 and I press enter, the entire sequence changed. It's no longer the original Fibonacci sequence. 2, 7, then 7 plus 2 is 9, and 9 plus 7 is 16, 16 plus. So that way a new sequence emerged. But this did not change. So shall we try with two other numbers? Let me try something 33 and 25. Again, there's a new sequence, but this does not change. Of course, the decimals may change slightly, but rounding off to 3 or 4 decimal places, it remains the same, right? Well, so there's something going on here and we need to justify this mathematically, why this is not changing. Why this golden ratio is still stable. Okay, so this is something we got to answer. So I want to come back to 1 and 1. Okay, the next one was again something interesting. Now I'm going to do it a bit faster now. I'm going to take ratios of B4 upon slash B2. So I'm going to take ratios with gaps of 1. So the formula will be here, inserted here in cell D4, which is equal to B4 upon B2. Press enter and double click in the corner. Now what do you observe? Something is happening here as well. And if I reduce the column width, I will see that this is also steadying out. Let's say, let's suppose I mark this in red. 2.618034, which is just one more than this. So this golden ratio is represented by the symbol phi, or 5 if you like. So this is phi and this is p plus 1. So something is going on here. We need to be clear about what is going on here, right? So we need to, first of all, let's just justify why this is there 1.618. Whatever sequence, okay, now let me change and you have a look at whether this is changing or not. So let's take, give me anything, suppose 26 and 13, okay, say 17. So whatever you do to these initial numbers, these ratio values seem to be independent of that. And that requires a mathematical explanation, right? Okay, so let's see. Some magic is happening here. So let's get into the bottom of the. Okay, Are you able to now see my PowerPoint slide?
Yes, but Jonaki, can you please give that formula which you put for the third column? I
Yes,
missed it.
sure. Yes. So here in this cell, I inserted B4/B2 equal to B4 because I wanted 2 upon 1. So I just clicked on these two cells, right? Equal to B4 / for division B2.
Thank you.
As you can see in the formula bar, it is showing, right? And that is because we want gaps of 1. If you wanted gaps of 2, next time you can do, you should explore more. So you can do this upon 1, 3 upon 1, and so on. Gaps of 2, then gaps of 3. Each time the column will steady out somewhere, and those values may have some connection to do, something to do with phi, right? That's what we want to look at. Can you see my PowerPoint slide right now?
Yes.
Okay. So let's answer this question. See, I'll just do a quick. So the Fibonacci sequence tells us that f of n plus 1 is equal to f of n plus f of n minus 1. Written in the recursive form, the n plus 1th Fibonacci number is the sum of the nth plus the n minus 1th Fibonacci number. Okay. And what I observed in that column, now you have to think of the column. I can't show you both simultaneously, but you have to think of the column which steadied out at the value 1.618034, right? This was the steady value. That column, we found that after a certain value of n, the ratios were not changing. So f of n plus 1 upon fn was equal to fn upon fn minus 1. Right? So, is this clear? That after a certain value of n, the ratios were stable, were not changing. So, f of n plus 1 upon fn was equal to fn upon fn minus 1. But then, if in this relation, we want to show that this ratio actually converges to this. So, let's suppose this upon this is equal to x, some value x. What do we want to show? We want to show that x is actually 1.618. Okay, so why are we writing this relation? Because after a certain value of n, we found that like the 20th upon the 19th was equal to the 21st upon the 20th and so on. So some value of n was there for which this is true, and let this ratio be x. Now I can use the relation 1 here. I can replace the f of n plus 1 by fn plus fn minus 1. So I'm just rewriting this with this, replacing this with. So f of n plus 1 is this upon fn is equal to the same thing here on the other side, right? Which is of course equal to x. Now if I simplify this, what will I get? I will get fn upon fn is 1 plus fn minus 1 upon fn is equal to fn upon is n. Now can we write this in terms of x? Because I already know that this is equal to x. The right hand side is equal to x. But what is this equal to?
1 plus 1 by x is equal to x.
Excellent. So 1 plus, because this is the reciprocal of this. So 1 plus 1 upon x is equal to x. Can you simplify this further and tell me what equation you get?
X square minus x minus 1 is equal to 0.
So we get a quadratic equation, right? What are the roots? X will be equal to minus b, so 1 plus minus square root of b square minus 4ac upon 2. So any class 10 child can understand this. Root 5 upon 2, right? But if I take 1 minus root 5 upon 2 as the value of x, that's not permissible because it will give me a negative value, you know, and this is a ratio. So I would like to ignore the minus and I would like to go with only 1 plus root 5 upon 2. You can simplify this on the spreadsheet or using a calculator, and this is nothing but 1.618 rounded to 3 decimal places. And notice that when we did this derivation, did we talk about the first two values of the sequence? Did we use the fact that the first two values of the Fibonacci sequence are 1 and 1? We did not. This entire derivation was independent of the choice of the first two numbers. And therefore it was happening. Whatever you do, ultimately your equation is going to be this only, na? X square minus x minus 1 equal to 0. Now, what is this symbol? This we denote this with the symbol phi. Okay, this is called the golden ratio. It's an interesting thing to see how artists will use.
Jonaki, voice is not heard.
Yeah. It's not heard.
There's some disturbance in your voice.
Now,
ma'am, voice is not audible.
Yeah, now it is clear.
Now it's okay.
Yes.
Oh, sorry, I don't know why that happened. Okay, so I was saying phi is the golden ratio, 1 plus root 5 upon 2, also 1.618. And this satisfies this equation, right? I mean, we solved this quadratic to get this, right? So I can say phi satisfies, so phi square minus phi minus 1 equal to 0. So that also leads us to the fact that phi square is equal to phi plus 1. So in the spreadsheet, if you notice, the second column had 2.618. So if you square 1.618, the square of this rounded off is also 2.618. So it's all related, you know. So we saw that in the second column, when we took ratios of successive terms with gaps of 1, that ratio was converging to 2.618, which is phi plus 1. But it is also phi square. So it all falls into place. So when you mathematically try to justify it, it all works out. Okay. So there is a video which I'll share with you, which again gives all this derivation. So don't worry if you've missed any part, but we can't just stick to one problem. I remember I showed you 7 and it's already 5 and we are just still at the first one, but that does not matter. The whole point is that we need to understand what we are doing. But this is the reason why the column was steadying out at 1.618, no matter what we chose as the initial values of the sequence. I hope you enjoyed this exploration. There's a lot more you can do, but I'm not going to get into that. But there is something called the special sequence that you see on the screen. This is a set of sequence of continued fractions. These are called continued fractions. And if you calculate the values of these, they're very interesting. You will notice that the first value is 1. Then the second is 1 plus 1 upon 1, which is 2. The third is 1 plus 1 upon the previous term. So there's a recursive nature of these continued fractions. The third one value is 3 upon 2. The next is 5 by 3 and so on. So this is nothing but the ratios of the terms of the Fibonacci sequence, and this sequence whose values are given by this also converges to the golden ratio, which is this, right? So there's so many things to explore in this one problem. And you might, when I generally do this with younger children, they say, ma'am, but we can get a Fibonacci number if you know the previous two numbers. But is there a formula which can generate any nth Fibonacci number? A kid of class 9 actually asked me this when I did this. And I was really amazed. I said, yes, there is. But, the derivation of that is probably slightly beyond your level. Maybe you come to class 10 or 11, then I will tell you. And they said, no, you have to tell us, ma'am. And then, I had to take an extra class and do a whole derivation to show them how you arrive at the nth term, nth Fibonacci number. So we must never underestimate our students. Believe me, they are always looking for newer. So how did the audience like this problem? Do you think it's a good exploration? Do you think you can do it with your children at whatever age group you feel that is appropriate? It will be nice if you try it. And, so you can link it with the history, with stories of Leonardo of Pisa, and, you can actually bring it to, you can also give them I think you can give it to them as a project to explore more about the golden ratio and so on. So are you ready and geared up for the next problem?
Yes, ma'am, they are putting up on the chat.
Yes, thank you. I don't know if you can see the title of the screen. Can you see what is written on the title bar?
Yes, ma'am. The spaghetti problem.
Yes, the spaghetti problem. Yes. It's also called the stick problem or something like that. Okay. So the problem is right in front of you on the screen. There's a spaghetti stick of length L. And you break it into 3 parts. Normally, when you bend a stick, it generally does not break into 2 parts, they say, but that's another problem. Maybe the physicists can answer that question. But they will break into 3 parts, let's say. Now, when you try to join those 3 parts to form a triangle, they may or they may not form a triangle, right? So there will be some cases where the broken parts form a triangle. There will be some where the broken parts do not form a triangle. But what is the probability that these 3 parts will form a triangle? So that is the question. So this is a problem in geometric probability, we can say, but let's try to understand. And we'll of course solve the problem on a spreadsheet. So see, what the problem says is, this is the stick, let's say this is a stick of length L, right? The total length is L. Let's say it breaks into 3 parts. So the length of the first part is X, the second part is Y. And obviously then the third part will be L minus X minus Y. Okay. Under what condition will these 3 lengths, so there are now 3 pieces, one of length X, one of length Y, and the third one is of length L minus X minus Y. Under what condition will this form a triangle? Can the audience share any?
Time, the sum of 2 sides should be always greater than the third one.
Yes, the triangle inequality, right?
Yes.
So from that we would get either we need that X plus Y should be greater than L minus X minus Y.
Yes.
So if these 2 pieces, it should be greater than this. What does that lead us to? What equation do we get from that? We can take the X and the Y. So we get 2 times of X plus Y is greater than L, or X plus Y is greater than L by 2. Or we need that maybe X plus this should be greater than the third side Y. So any 2, right? We can take any 2 of these 3, and that should be the sum of that should be greater than the third. That's what our triangle inequality is, right? So what will we get from here? Now I'm in the second case. First
L
case,
minus Y is greater than Y.
so L is greater than 2Y. So Y is less than L by 2. Right? Now I take these 2. So Y plus L minus X minus Y is greater than X. What does this give us? Y and minus Y. So X will be less than L by 2. So we get these inequalities emerging from the triangle inequality itself, right? So, okay, so now what happens is, in general, X is the length of one of the pieces. Y is, let's say X is the length of one piece, and Y, X can take any value from 0 to L, right? Of course, if X is the whole of L, then that's also one possibility. But that's one of the extreme cases, which will not happen, right? But if I want to represent this, I lost what I wrote. But anyway, so what if I want to represent that, what happens is that, say on the x-axis, I go from 0 to L. So I mark all the values of x. X is the first piece of the stick. And the y, on the y-axis, I mark the lengths of the second piece of the stick, right? And the value of x can go from 0 to L, and the value of y can also, but x plus y must be less than L, no? Because x, if there are only two pieces and they form the entire stick, then obviously x plus y has to be less than or equal to L. So x plus y equal to L is this line. If you plot the line as a linear equation, x plus y, if this is L0, if this point is L0 and this point is 0 comma L, then x plus y equal to L is this line. But we also got an inequality that x plus y should be greater than L by 2, right? From the first condition. So if I take this is the midpoint, so this is 0, this is L by 2, 0. And here also this is L by 0, L by 2. If I join these 2 points, I will get the equation x plus y equal to L by 2. But this is a linear equation. I have a linear inequality which says that x plus y must be greater than. So it should be on this side. So I'm going to get a feasible region. So I have 2 conditions. X plus y should be less than or equal to L, which means it should lie on this side of this line. I have this condition, which means that x plus y should be greater than L by 2. I also had the condition that x was less than L by 2 and y was less than L by 2. Okay. What about x equal to L by 2? X equal to L by 2 is a straight line parallel to the y-axis passing through this point. So this line is x equal to L by 2. But x less than L by 2 means that the solution should be on this side. And y equal to L by 2 is a line parallel to the x-axis. And y less than L by 2 would be below this line. Now, do you see these arrows? What are they pointing to? So what I need is a feasible region, the common region to all these inequalities in the first quadrant. What does it indicate, the common region? Where do you think, what solution will be common to all these 4 inequalities? X less than L by 2 is on the left side of this line here. Y less than L by 2 is below the line. X plus y is less than equal to L and x plus y greater than equal to L by 2. So if we have all these 4, they have to be satisfied all together, then which part will I take? Which is the common feasible region is what I'm asking.
Ma'am, someone said middle part.
Yes. Middle part, you see these arrows, this middle triangular part, this part is common to all the shade. See, if I have a shaded region, you know, which let me take another color. If I have a shaded region for this one, right, for this line, then I have a shaded region for this line. Then I have something below this and I have something on the left side of this. Ultimately, what is common to all these 4 inequalities will be only this triangular region. Okay. So this is now the new shading that I'm doing, black. So can you tell me the area of this triangle? It's a right angle triangle. What is
L square by 8.
L squared by
8.
So, sir, let me give this point A, let me call this B, this point, and let me call this C, right? So triangle ABC, area is what? L square by 8.
8.
Okay. So this represents all those cases where the spaghetti stick, when broken, will actually form a triangle, right? Do you agree with that, sir? Does the audience agree with this, that these represent those cases where the three sticks will form a triangle, because this triangle has emerged from these inequalities, and these inequalities represent the triangle inequality, which says that, But if I take this whole big triangle, what is the area of this whole big triangle? The whole big triangle represents the entire sample space. So the probability of obtaining a triangle will be the favorable cases upon the total number of cases, right? So the probability will be favorable cases, which is L square by 8, upon the total number of cases, which is represented by the area of this entire big triangle. What is the area
L
of this?
square by 2. L square by 2.
L square by 2. Half base into height, right? How much is this? L square.
1 by 4.
So the theoretical probability that if you break a spaghetti stick, the three pieces that you get will form a triangle is actually exactly 1/4, the theoretical probability, right? Okay. So this is the analysis of the problem, right? But let me now take you to this. So these are the steps how we are going to simulate it. Let's simulate it now on the spreadsheet. Let's see if I can manage to. Okay. Right. Okay, so let me, as usual, let me bring in a serial number column. Let's say I want to break 100 spaghetti sticks. Okay. So I can't actually physically break sticks and start measuring their lengths, right? So I need to simulate this experiment somehow. Okay, so let me quickly do this. So when we are simulating, we are going to, sorry. Okay. So what I'm going to quickly do is I'm going to enter a serial number. So let me just highlight these for you in blue so that you can for better visibility. So what I'm going to do is I'm going to randomly see if I have a stick and there are two cuts. So let's assume there's a stick of length 100 units, whatever that 100 may be. And I want to select two random numbers between 1 and 100. And these two random numbers are going to represent the cuts, right? The first cut, so let's say the first cut is at X and the second cut is at Y. But both these are numbers between 0 and 100, 1 and 100, let's say. And then I'm going to ABC represent the three sides of the triangle. So I'm going to use conditional statements to actually assign values to ABC and then check from the condition, does it form a triangle or not? Okay, so let me quickly show you. So I'm going to enter 1 in this. I'm just going to have a serial number from 1 to 100. So I'm going to say, like we did before, previous cell plus 1. But if you don't want to drag this all the way up, I can drag it. But if you don't want to drag it all the way up to 100, there's also another way to do it. You can go to the fill. We can go to the fill option. If you can see the fill option on your spreadsheet, that's fine. Otherwise, you can just drag and do it. But there is within fill, there's a series option. So series may you go to columns and you say that the step value should be 1 and the stop value should be 100. That means you want a sequence of numbers from 1 to 100 and you say okay. So if you do that, you'll quickly get, suppose you want a sequence of numbers from 1 to 500. So it's a bit difficult to keep dragging till 500. So I have just used the fill command. Within the fill command, the series option. Okay. All right. Now let me just center align this. Okay. Now the first cut on the line should be a random number between 1 and 100. So Excel has this rand between command. So if I type R, automatically rand or rand between will come. Otherwise, you can type it. So what does this mean? It will randomly pick a number between 1 and 100 and it will generate it. So you'll have to type equal to rand between. When you type rand, Excel will offer you the command. You just select the command and within round brackets, you type 1, 100. Okay, so let's press enter. Like in your case, it may be different because every number is going to get randomly generated. But my first value is coming out to be 80. So I selected a number between 1 and 100, right? Okay, now Y also should be a number between 1 and 100. So what I will do is I'm just going to drag this to the next cell. Notice that the first number changed. That doesn't matter because every time you click on the sheet or you click on the cell, a new random number between 1 and 100 will get generated. Okay, now before you try it yourself, let's just understand what is happening. See, the first cut, the first break is at say 43 units and the next break is at 87 units, right? So I should have that the length of my one side is A, which is 43. The next length should be 87 minus 43 because this is from 1 to 87. So the first 43 units is taken up by side A. Then 87 minus 43 should be the next side and the balance of 100 of the sum of these two should be the third side, right? Is the idea clear?
Yes, Jonki, but I have a problem.
Yes.
You are having this column X 43 that's smaller than this number 87 Y, but I'm getting 43 on X and in Y I'm getting 4. So is it okay?
Yes, yes, it is okay.
Yes.
So the smaller value will be assigned to A. Okay. So now I will enter in A, I will enter this if condition. Okay. If bracket. What does the if condition say? If this cell is less than or equal to the next this cell. So if condition is like this, you can see Excel is telling us a logical test and what happens if it is true and what happens if it is false. So if the value of X is less than the value of Y, then A should be assigned the value which is in cell B3, else it should be assigned the value which is in the next cell, which is C3. Is the idea clear now? So yeah, now the first X is 20 and the second one is 42. That means the side length of A should be 20 only, lesser one of these two. Okay. So this is 20. The next one should be 42 minus 20, which is 22. So this if condition does that. It tests. If this is less than this, then the value here will be, with this condition, the value here will be the lesser one of these two, whichever it is. Let me try again. So again, so what it has done is it has generated all since I double click. So let me do this. I don't need to do it right now, but okay. So say 15 is my first length, X. Second length is 26. So 15 should be assigned to A. The smaller value of these two should be assigned to A. So ma'am, are you getting it now?
Yes, yes.
Okay. Now the second one will be what? If this cell is less than this and the value of A has been assigned to the smaller value, the second one should be this minus this. That is the condition which I should put, right? So what I will do is I'll try to take you to an already created sheet. Let's see here. This is a serial number. Okay, this is 37. So what happened is these are two random numbers. So I'm going to highlight these in red. or just for your understanding. These are the two cuts. Now here see what has happened. Here obviously y is a smaller value. So the a has been assigned a smaller value. The difference of these two is 9, which has been assigned to b. So the first side is of length 28. The second side of the triangle has length 9. The third side will be the 100 minus the sum of these two. And then it checks. There's a condition which checks, is a triangle formed? No. So let's see these conditions. So A, I already told you that if B2 is less than or equal to C2, then B2 LC2. That is the condition. For the second one, I will say if B2 is less than or equal to C2, then the length here should be C2 minus B2, or it should be B2 minus C2, whichever is applicable. And the third condition should be 100 minus the sum of these two values. If you follow this logically, then you will get it. And the third last condition checks, is a triangle formed with these three side lengths? If A is 28 and B is 9 and C is 63, is a triangle formed? And that can be checked by the condition which say that if the maximum value of these three values is less than 50, then only the triangle will, because my spaghetti length is 100 units. So the maximum value of any side length should be less than 50. Then only the triangle will be formed. L by 2, 50, right? Otherwise, triangle will not be formed. So what this sheet has done, it is a simulated 100 spaghetti sticks, and it has generated the side lengths. And in the last column, it is checking whether a triangle is formed or not. Okay. So let me go back to the unfilled sheet and let me do this one. Okay. So second one was, so A was if B3 is less than or equal to C3, then B3 LC3. The third condition will be if sorry, just let me check it once. Yes, correct. Okay. Here I will say equal to if B3 is less than equal to C3, comma, then we will say C3 minus B3, else it will be B3 minus C3. This is the condition. Let's check. Now let's check carefully. See, the first length is 15, the second one is 49. So A has been assigned the smaller value, which is 15, and B has been assigned the difference of these two, the next length. What should C be? C should be 100, the total length minus the sum of these two sides. So I'll just type 100 minus the sum of these two values in these two cells. So again, let's check. Now let's see. See, every time you tap, the values are changing. But now 51 is X and Y is 46. So A has been given the smaller value 46. The difference has been assigned to B. And the third value is the 100 minus the sum of these two. Does it form a triangle? So I will say if, the condition here is if the maximum value of what? These three. Click on D3, comma, E3, comma, F3. If the maximum value is less than 50, that is half the length of the stick, then only triangle will be formed. So we will say yes, else we will say no. This is the under column G where you are checking if the condition has been satisfied or not. Right? No. In this case, a triangle, you can check. If the three sides of a triangle are 15, 8, and 77, then surely a triangle cannot be formed. Right? Now what we do is you click on this cell and you click on the last, press shift. So I repeat, click on the first cell under X, click on the last cell under at the end of the row under G after pressing shift. So it will select all the cells and you double click in the corner of this when the cursor becomes a small. Sorry, it's not. By double clicking, there's a problem with my connection, I think. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yeah, I don't know why this is not coming. It should come if you double click. Are you getting it by double clicking? I'm going to do it individually. It should have come all together actually. Some problem. Okay, now the thing is that now I need to count how many are yeses in this column, because out of these 100 simulated spaghetti sticks, how many yeses are there? How many cases are there where a triangle is actually formed? So the number of cases where the triangle is actually formed upon 100 will give me the probability. Okay, so let me take you back to the already made sheet. Now see here, the probability for this data is coming out to be 0.28 because this is an empirical probability. So if I double click on this cell, see now the probability is 0.25. I can click anywhere on this X and Y. So you see, if you keep clicking, every time you click on this sheet, you get 100 different, you are simulating 100 breakings of the stick. It is like that. So simulation means you are not actually doing it. You're not taking actual sticks, but you have simulated it by generating random numbers. Okay. You will notice that all the time the probability of 100 sticks will hover around 0.25, but it will not be exactly 0.25, right? If I were to drag this and create a data for 1000, let's say, I will get close to 0.25 much faster. So the law of large numbers. If I simulate the experiment a large number of times, I will get closer and closer to 0.25. So what I was trying to say here is that this is a nice problem to explore, where you can discuss the problem through the classical probability, the theoretical probability approach, by using the triangle inequalities and to show the shaded region that is formed. And you can also simulate the experiment. So this is an empirical probability that you are getting. So for this particular 100 throws, our probability is 0.24. So spreadsheets are good in that way, because they help you to simulate experiments, right? So did you enjoy the second problem? We'll probably have just time for one more. Ma'am, can I go on till 10 to 6 or what? How much time do I have?
Yes, ma'am. Till 6 also you can go on.
Okay, thank you. All right, so this is a spaghetti problem. Again, it is all there on the slide, so I will share the slides with you. Now, let me take you to, okay. This is also an interesting problem. It's called the house number problem. So I'll try to do two more, so I may go a little fast, and then I'll share all the slides with you. So if you missed anything, you can always get it. Now, this is an interesting problem. It's known as one of Ramanujan's puzzles. Okay, there is a story behind this. So it says that P.C. Mahalanobis, the great P.C. Mahalanobis, was in Cambridge at the same time as Srinivas Ramanujan was. And one day, he visited Ramanujan, and Ramanujan was cooking. And he said, in the Strand magazine, that's a very famous mathematical magazine at that time, he said, I came across this problem and I've been trying to solve it. I think I've got the solution. So Ramanujan was cooking. So he said, can you read out the problem to me? So he reads out this problem. And then immediately Ramanujan just tells the solution. He was such a fantastic mind. It's still an enigma how his mind actually worked. But he was more than a genius, I think. Anyway, so the problem is famously became known as the house number problem. It says, my friend's house is on a long street where the houses are numbered 1 to 3 and so on. So the numbers on the street are, houses are numbered from 1, 2, 3 sequentially. All the numbers added up on one side of my friend's house is exactly equal to the house numbers on the other side. And there are more than 50 houses, but not as many as 500 on the street. So the total number of houses on that street are between 50 and 500. So what is my friend's house number? That's the question. the houses are numbered 1, 2, 3, 4, and so on. We don't know how many houses there are. So let's say there are n houses. It's an unknown, right? All we know is that n lies between 50 and 500. This is from this sentence. There are more than 50 houses, but not as many as 500. So n lying between 50 and 500. Let's say m is my friend's house number. So we need to find m and n such that the sum of all the house numbers to the left side of m is equal to sum of all the house numbers to the right side of m. Am I making sense? Please take a minute to go through the problem yourself and then let me know if so we need to find m and n. M is my friend's house number, n is the total number of houses on the street. Is the idea clear? The question is clear?
Yes, yes.
Yes, ma'am.
Okay. Now see, what is the number to the previous to this m? What should I write? The previous term of this?
m minus 1.
M minus 1.
1. And the one after this?
M plus 1.
M plus 1.
Plus 1.
Very good. So this sum should be equal to this sum, right? Now this sum, we know the formula that the sum of the first n natural numbers is n into n plus 1 by 2, right? This formula is done in school also. The sum of n natural numbers, first n, is n into n plus 1 by 2 for any n. So what will be the sum of the first 1 to m minus 1? We replace n with m minus 1. So what will we get?
Plus 1 upon
M minus 1 into m upon 2. If the sum of the first n natural numbers is n into n plus 1 upon 2, we replace n with m minus 1 because I am only taking sum of the first m minus 1 natural numbers. So m minus 1 into m upon 2, right?
correct.
Okay. Now I need to write a sum for this star m plus 1, m plus 2 all the way up to n. But we don't know what are m and n, right? So this sum perhaps can be written as the sum of this entire sequence from 1 to n minus this sum. So this part from m plus 1 to n can be written as n into n plus 1 by 2 minus m into m plus 1 by 2. Am I right? To get this portion, I am going to add all of these and subtract till here. The sum of the first 1 to m is m into m plus 1 by 2. And the sum of the whole thing is n into n plus 1 by 2. So the difference is this sum. Because the condition of the problem is that the numbers added up on one side of my friend's house is exactly equal to the number on the other side. So this is equal to this. Because somewhere we have to make a guess for m and n. We can't solve directly. But what are we getting any condition which is useful? So let's see. If I solve this, I am going to get m square minus m upon 2. Here I am going to get n square plus n upon 2 minus m square plus m upon 2 inside a bracket. So what does this lead to? Can you simplify please quickly and tell me what it leads to? we get m square minus m is equal to n square plus n minus m square minus m. This is n here. What cancels out on both sides? So the condition I get is 2m square is n into n plus 1, this n square plus n. I'm just rewriting it as n into n plus 1, or m square is equal to n into n plus 1 upon 2. This is important. This is what we have got from the condition of the problem, which says that wherever my friend's house is, let's say m is the house number of the friend, then the sum of all the house numbers to the left is equal to sum of all the house numbers to the right. That leads us to this condition between m and n. Now the left hand side is a perfect square. It's a square number, right? What is the right hand side? It's of course the sum of the first n natural numbers, but it is also something else. So let me move on. I'm not getting any response, so I'm just going to move on. Okay. So what we have is, see, our condition was that m square is equal to n into n plus 1 upon 2. This is the sum of the first 10 natural numbers, but this also happens to be the formula for the nth triangular number. So what are triangular numbers? Triangular numbers are like, you can use dots to represent them. So 1, 3, then 6. So you keep making triangles, you keep scaling up the side lengths, and the total number of dots used are actually the triangular numbers. So first triangular number is 1. The second triangular number is 1 plus 2, which is 3. The third triangular number is 1 plus 2 plus 3, which is 6. The fourth triangular number is 1 plus 2 plus 3 plus 4, which is 10. Can you tell me what will be the fifth triangular number?
15.
1 plus 2 plus 3 plus 4 plus 5, which is 15, very correct. So the nth triangular number is nothing but 1 plus 2 plus 3 up to all the way up to n, which we know is n into n plus 1 by 2. So n into n plus 1 by 2 is the formula for the nth triangular number. So I'm looking, to solve this puzzle, I need to find a triangular number which is also a square number. Okay, so let's quickly write down the triangular numbers. You already told me quite a few of them. So 1, 3, 6, 10, 15. What will come after 15? The next triangular number will be adding.
Someone has put up on the chat 21.
51, very good. What about the next one?
28.
Very good, fantastic. Next?
34.
28 plus 8.
36.
There's some problem, some sound. Yes, very good. So 36 is a square number, isn't it?
Yes.
So 1, 2, 3, 4, 5, 6, 7, 8. The eighth triangular number 36 is also the sixth square number, because the square numbers are what? 1 square is 1, 2 square is 4, so on, 3 square is 9, and 6 square is 36. So if I take m to be 6, m square is 36, and if I take n to be 8, because the eighth triangular number is 36, so does it satisfy this equation? Does m equal to 6 and n equal to 8 satisfy this equation? Please tell me.
Yes, madam.
Yes, ma'am.
So if there are only 8 houses on the street, so let's number the houses. 1, 2, 3, 4, 5, 6, 7, 8. And 6 is my friend's house number. Then the sum of the house numbers here is 15, and the sum of house numbers here is also 15. So definitely this is one solution, but it is not the solution to my problem, because that problem says that, in the street There are more than 50 and less than 500 houses. You agree with me? So this is one of the possible solutions. Had that constraint of 50 and 500 not been there, then definitely this is one of the solutions. So what the trick is, we need to look for square numbers which are also triangular numbers. Okay, since time is less, let me quickly take you to a spreadsheet. A spreadsheet will answer the problem for us. And okay, let me go. Right. Now I'm going to do a little fast. Serial number. In this column, I'm going to have the triangular number. And here I'm going to have the square numbers. You can just watch. Okay. So again, headings in blue, bold, center aligned. Okay. Now I need to generate a sequence, serial numbers right from 1 to, actually 50 to 500. But let me just do it from 1 to 500. So I'm going to enter 1 here. Here equal to this plus 1. And this formula, I'm going to use the fill command like I did before. Go to series, go to columns. Starting value is 1 and the ending value is 500. So I've got this big column from 1 to 500. You can scroll down and see. I'm going to center align these columns for better visibility. Okay. Now, what is the formula for the triangular number? Nth triangular number was given by n multiplied by n plus 1 upon 2. So I'm going to use this column A is the value of n. So just click on this cell, A2 multiplied by A2 plus 1. A2 is n slash 2. N into n plus 1 upon 2. So tap enter. And the square number is going to be simply the square of this. So you click on A2 raised to the power 2. So I repeat, in this cell I've inserted the formula for the nth triangular number. In this cell I've inserted the formula for the nth square number. Now I try to, let's see if it works now. It should work. So I double clicked, I selected both the formula cells and I double clicked and I got this. Now I need to search, see, the sixth square number, 36 is also the eighth triangular number, 36. So let us, we know this, we've already got this answer. So 6 was the friend's house number and 8 is the total number of houses on the street. But that doesn't work for my problem because 50 and 500 ka constraint hai. Okay, so I need to search, I need to scroll down and see, are there common values in these two columns? 36 is 1. Is there anybody? Can you see anything? So you have to keep scrolling down and check, keep your eyes on both the columns. Obviously, they will not come together. That is why there's an N and there's an M. So what I do, this is very nice. If I select these two columns, there's a conditional formatting option here in Excel. If I go to conditional formatting and ask Excel to mark the common values in these two cells, I go to highlight cell rules and come to duplicate values. You'll find conditional formatting. See, the versions may be slightly different, but somewhere you will find conditional formatting. So I went to conditional. First, you have to click the two columns. Select the two columns by pressing Shift. So I'm going to repeat this. See, I click on this B, I press Shift and I click on the C. So both the columns are selected. I go to conditional formatting, highlight cell value rules, and the rule is duplicate values. So when I click on this, it tells me, should it mark the duplicate values? And you just say okay and see what happens. 36 though we had 1, 2, 2, 5. Okay. So 1, 2, 2, 5 is the square of 35. So what should 35 be? And 1, 2, 2, 5, sorry, 1, 2, 2, 5 is the square of 35, yes. And 1225 is the 49th triangular number. So can you tell me, if this was possible, what would be the friend's house number and what will be the total number of houses on the street? The square number, the n value of the square number, perfect square number, will give you the friend's house number. So friend's house number would have been 35.
35.
If there were only 49 houses on the street. Right? So this pair tells me that my if this m value could be, m value is the friend's house number, so m can be 35 when n can be 49. But that also doesn't satisfy, because they are saying there are 550 to 500 houses on the street. इसमें तो सिर्फ 49 houses allowed है. So let's go ahead and check for more. You see, it's rare, it's quite sparse. You don't find too many numbers which are commonly both square and triangular numbers. Oh dear. Here is another one. 41616 is the perfect square of 204. Please remember that number. And 41616 is also the 288th triangular number. So 204 can be the friend's house number, and if there are 288 houses on the street and my friend's house number is 204, then all the house numbers to the left is equal to all the house numbers to the right. And there aren't any more possibly in 500.
राघु आवाज नहीं येत आहे.
So the solution to Ramanujan's puzzle is what? Actual solution? I hope it was clear. So the solution was that
204.
M, the friend's house number, is 204 and the total number of houses on the street is 288. This lies between 50 and 500, so it satisfies the condition, and you can check. So 1 to 203, if you add up, whatever is the value should be the same as 205 till 288. That sum should be, you can check it later. But if this constraint was not there, then there are many solutions. M and N, what possible value is 6? House number is 6, total number of houses is 8. We got this on the spreadsheet also. Then house number can be 35 and total number of houses can be 49. The next solution was house number is 204, total number of houses is 288. And if there's no constraint, then indefinitely you will find infinitely many solutions, though it may be hard to look for them. But you see, to analytically solve this, you have to know number theory and you have to solve something called Pell's equation, which may not be within the purview of children, of younger children, but the spreadsheet allows them to easily check and verify and find solutions. So numerically, the problem can be solved to some extent. So that is why, that's the beauty of technology. The beauty of technology is not in the technology per se, it is in the problem and how you use the technology to solve the problem and to, to push children into. What did Ramanujan say? He quickly told Mahalanobis that, look, this continued fraction, this is a continued fraction. He says this continued fraction gives the solution. So these solutions can be obtained from this continued fractions. So there's something called the convergence to this continued fraction and so on. Okay, so the first convergent is 6, which is the answer. The next will be 6 minus 1 upon 6. Convergent means you just take a portion of the continued fraction. So 6 minus 1 upon 6 is 35 by 6. So 35 is the next solution. 6 is one solution. The next convergent, in which you will include 6 minus 1 upon 6 minus 1 upon 6 will give you the next value, and so on. How did he guess it? So his mind was always, he had such a great understanding about numbers and the relationships and formulae that things just occurred to him instantly. Okay, so it's just 5 minutes left, so I have no choice but to wind up.
We just want to tell you to continue, your lecture, but it is not possible.
I know that.
It was very, very interesting. Yeah.
Yes, actually, there is a whole play. These are more for longer workshops. So I'll just share very quickly and wind up. So I'm not going to solve the problem, but they're very interesting problems. Like, for example, this one, where it's called a counterfeit coin problem. This doesn't use technology, but it simply says that there are 9 identical coins which look exactly the same, but one of them is a faulty coin which weighs maybe little less or maybe little more than the others. Let's say it weighs a little less than the others. So what is the minimum number of weighings required to identify the faulty coin? And no weights are available. So there's a balance. You can weigh the coins against each other, right? So when this kind of a problem is thrown to children, because it does not require the knowledge of any formulae or any particular theory, they start thinking innovatively. So students, actually, so we gave them tasks like, you can design a task and say, okay, what happens if the question is asking about 9 coins? And what is the minimum number of, they all look the same, so you can't figure out. But how many weighings will you need to weigh the coins against each other and find out which is the faulty coin? So therefore, children were, then they said, okay, let's see what happens if there are 2 coins, 3 coins, 4 coins, and up to 9 coins. Is there any pattern and so on? And then, then they try to see a pattern and generalize the pattern. Students started, giving their own strategy. So some children said, look, there are 9 coins. You divide them into 2 sets of 4 and 4 and keep 1 coin aside. Now, if these 2, 4 and 4 are equal, then obviously the leftover coin is the faulty coin, because the faulty coin is slightly heavier, let's say, than all the other coins. But then the problem is, if one of these 2 sides, if there are 4 on one and 4 on the other, then one of these 2 sides is heavier, then those 4 will have the faulty coin. Then you'll have to weigh again. So another group says, no, that will not work. We should make 3 equal sets. So if there are 9 coins, you make 3 coins, 3 sets, and you weigh any 3 coins with the other. So suppose these 2 are equal in weight, then the third one obviously has the faulty coin. So in one weighing, you can get to know which set has the faulty coin. And when there are only 3 coins, then it's very easy, because you take any 2 and weigh them against each other. From that, you can guess which is the faulty coin. So only 2 weighings are required for 9 coins. So they drew a decision tree, and this is children's representation, students' representation of the problem. That if you number the coins 1 to 3 until 9, these are the possible cases, and the cases were marked and represented using a decision tree. This led to a huge project because there are many variations of this problem. They started creating their own problems and describing their solutions. Like this was a special case of 15 coins. So this group did a project and they did some color coding. So they divided the coins into 3 sets of red coins, blue coins, and yellow coins, numbered from 1 to 15. And then they submitted their solution as this decision tree. So I would like to conclude now. I'll take you quickly to the last slide of the presentation. So why technology? There are many, the cognitive aspects of technology. This was given by the researcher called P, who said that, technology develops our thinking, it works like an amplifier and also as a reorganizer. Why amplifier? It restructures our thinking, increases the range of activities that we can perform in a limited time. So it can quickly, technology can create a lot of graphs, or it can, for example, you saw on the spreadsheet, very quickly it generated, 500 square and triangular numbers. You can't do this by hand. So basically, the short time, you have access to a larger data so that you can start seeing patterns, you can start recognizing patterns and make generalizations. So it amplifies our thinking. It is also a reorganizer. It emphasizes processes such as search for patterns and problem solving. It enables learning by exploration and discovery. And when you use technology, you cannot use the traditional mode of teaching. You have to restructure your teaching. So my experience of using explorations has been that student feedback has been excellent. Whenever you give them these projects, they own their projects. They are responsible for their learning. They engage in group work, and it can be adopted online. Technology works like an amplifier because students work more effectively. They outsource the calculations to the tool, but they focus on reasoning and on developing more insight. but you have to give them the right kind of tasks. Textbook problems cannot be adapted directly to technology. Technology is a reorganizer. It gave them access to higher level concepts. Meaningful tasks were posed, but outcomes were not predetermined. Even as a teacher, I may not know what will be the final outcome or answer of the problem. So there's a suspense, there's an atmosphere of suspense and many aha moments, when children come up with some discovery of their own. They asked many what if questions. Coming back to the first slide, when David Wheeler says that, we must encourage children to ask what if questions. And they present their projects in fairs and competitions, which is most important, that they own their projects, so they're proud of it and they want to. So I would just like to conclude that that using explorations, you can really bring about the shift from content to processes. The relevance of mathematics can be highlighted, and the considered use of technology may help to restore the balance between the need for computational skills. So it's not that procedures and hand calculations are not important. They are very important, but explorations are also important, and we have to strike the balance. And I would like to end with the quote by the great George Polya, who said that, a great discovery solves a great problem, but there is a grain of discovery in the solution of any problem. Your problem may be modest, but if it challenges your curiosity and brings into play your inventive faculties, and if you solve it by your own means, you may experience the tension and enjoy the triumph of discovery. So with this, I close, and apologies for overshooting the time, but I hope you like the 3 problems that we looked at, and I will share.
Thank you, Jonaki, for the very intellectually stimulating session. I think we have enjoyed the joy of problem solving in mathematics, and you have taken us through a very practical session. So you have a lot of compliments on the chat. Now we'll just go for the presentation of that small study which we have done on gender bias. So requesting Clarice and Daya to please present the study.
I'll stop sharing. Yes.
Oh, yes, ma'am. I'll share the screen.
Yeah, sure.
Hello, everyone. So as per our ongoing webinar series, along with that, we also conduct a small research, which is gender bias in mathematics teaching learning is the topic for recent research that we conducted. So there are various, biases regarding even mathematics, that is patriarchy in society, different policies that leads to gender bias, teachers socialized in typical way, facilities in school, parents' expectations, the biases that we see in the textbooks, and also there are biases in students. The UNESCO report of 29th June 2020 Global Education Monitoring Report by UNESCO says that women are underrepresented and portrayed in stereotype roles. Few female characters in textbook, passive and introvert, and need for a gender balance in the textbook. This was all about the UNESCO report. So now I will be presenting the results of the study that we conducted this time. And the objective of our study was to study the perspective of gender bias in mathematics teaching learning, to study the factors related to gender bias in mathematics teaching learning. So we had got 258 responses, and these are our questions. That is, girls are better in mathematics than boys. So 19% of the teachers had agreed to that. The next question was, male teachers can teach mathematics better than female teachers, and 15% of the teachers had agreed to that. The next question is, problems in mathematics are more useful to men. later in their career than females, and 15% of the respondents had agreed to this. Boys are quick in scientific thinking than girls, and 28% of teachers respondent has agreed to this. Mathematics subject reflect the patriarchal attitude, and 18% of the teachers had agreed to this. Teachers discriminate students on the basis of gender while teaching mathematics, and 14% of the teacher respondent have agreed to this. Boys solve sum quickly as compared to girls in mathematics, and 10% teachers had agreed to this. Male teachers are preferred for mathematics teaching rather than females in schools and colleges, and 16% of the overall responses have agreed to this. Textbooks are a major source of gender bias in mathematics teaching, and 24% of teachers have agreed to this. Teachers have prevalent gender bias while teaching mathematics, and 17% of teachers has agreed to this question. Now I would like to hand over to Daya to conduct the rest of the questions.
Yes, thank you, Clarice. So moving on with the 11th question. Mathematics requires male characteristics of perseverance and aggressiveness while solving problems. This was our 11th question, and 11% of the teachers in our survey agreed to this. Next question, please.
1 second.
Yeah. Yeah. Boys have a sharper mind when it comes to abstract thinking and spatial ability in mathematics. This was the 12th question, and there were 15% of teachers who agreed to this. Girls are underrepresented in math-related careers, and 40% of our teachers agreed that girls are really underrepresented. 14th question was the effects of culture creates the gender gap in mathematics learning, and almost 49% of teachers agreed to this. 15th question was girls are emotional, so they do not have a mathematical bent of mind, and 6% of the teachers agreed to this. 16th question was boys and girls have different mathematics anxiety, and 37% of our teachers agreed with this. 17th question was mathematics phobia would differ according to gender, and almost 20% of our teachers agreed with this. 18th question was parental gender bias affects the performance in mathematics, and 45% of our teachers agreed with this. 19th question was gender stereotypes are present in mathematics teaching learning, and 21% of our teachers agreed with this. 20th question was there are gender differences in confidence related to mathematics learning, and almost 25% of the teachers agreed with this. So the extent of gender bias that we found in the teachers' perception were like 22% of our teachers were gender biased. And variables leading to the gender bias in mathematics teaching learning, some of the variables as you can see here. General perceived differences between the genders, teachers' personal bias also could be a part of it, a patriarchal attitudes. The textbooks are highly gender biased. Perception about career prospects, the subject content, and the cultural effects. So these are the references for our study conducted. Thank you for your kind attention.
Thank you, Clarissa and Daya. And we come to a meaningful end of this webinar with a lot of learnings for implementation in our classroom. We had an excellent session by Dr. Jonaki Ghosh. And I now request Rachel, if you're there, to propose the vote of thanks. Rachel, are you there?
Yes, ma'am. Yes, ma'am. Hello, everyone. It's my privilege to propose a vote of thanks for SXI Maths Webinar Series 8 2021. On behalf of SXI Manager, Father Blaise D'Souza, Principal Dr. Sosamma Samuel, Staff in Charge Dr. Winnie Sebastian, I extend a hearty vote of thanks to our resource person for the day, Dr. Jonaki Ghosh, who spared time from her busiest schedule for this webinar. Today, we have been privileged and had this amazing opportunity to hear to your session on technology-enabled mathematics exploration as a catalyst to develop mathematics techniques. I am sure all this information will help us immensely in our respective fields. So thank you once again, ma'am. Next, I will specially thank our manager, Father Blaise D'Souza, and Principal Dr. Sosamma Samuel for allowing us to continue with Maths Webinar Series 8. I would like to thank and appreciate our staff in charge of Mathematics Pedagogy Unit, Dr. Winnie Sebastian, for motivating and encouraging us to continue with this webinar series. My heartfelt gratitude to our student coordinators, Alsona, Riesel, Clarice, Rachel, Daya, and Nisha for being the constant and strong support behind the curtain and providing technical support. And last but not the least, a big thank you to all the participants for your presence. Without each and every one of you on Zoom and YouTube, this event wouldn't be successful. We hope that you're taking back something with yourself from this session today. So once again, thank you for making this event a success with your enthusiastic participation. With this, I end my vote of thanks. There are some instructions regarding the feedback form. They are as follows. We will be posting the feedback from link when the session will come to an end. The link is already posted in the chat box of Zoom and YouTube. Please note later, no link will be posted on your WhatsApp group. Feedback form will be open only up to 7:30 p.m. While filling the form, make sure that you enter the correct email address. If you do not get the certificate, wait for some time or check your spam folder. Even after that, you do not get the certificate, then you can contact any of the student coordinators before 7:30 p.m. Thank you very much.
Thank you. Kudos to the team for organizing such a wonderful session. It has been a great experience. And the students, I think I really want to compliment you that you have managed everything so beautifully. And thanks to the entire team. Thanks to Dr. Sebastian and everyone. Thank you. Thank you so much.
Sosamma Samuel is here.
Yes.
Ma'am, you want
Yes, I am there. Thank you so much, Dr.
Thank you, ma'am. It was a pleasure and
such a wonderful seminar. So keep in touch with us.
Yes, thank you. I will share I will share the PPT also. So participants who might have missed a few things, maybe they'll be able to.
Jonaki, this recorded session will be put up on the YouTube. So,
It will be. They can follow that as well. Yes.
Yes. Thank you very much, Jonaki.
Thank you so much. Yeah.
Thank you.
Okay.
Thank you all.
Okay, thank you. Bye.
The feedback.
Thank you. Bye. Yes.
Okay, ma'am.
Okay, Winnie. Yeah.
Bye.
Bye.
All the best.
Yes.
All the best, Dr. Janaki.
Thank you so much, ma'am. Thank you.
Alsona, should I end the meeting?
Ma'am, we'll wait for 2 minutes. We'll wait for 2 minutes and then we can end.